kababayan, ang pambansang awit ng Pilipinas.
Good morning to all of you. This morning, we bring another seminar entitled 5G Networks, the Wave of Connectivity. To open this activity, let us have the Governor of the chapter, Engineer Julius Cedrosa.
Mayong buntag, kanatong tanan. Good morning. Morning. It's another Saturday and I am the governor welcoming you all this morning. So I am happy that we are here again, and to the participants, thank you so much for patronizing our webinars every month, and we are so thankful. Nagpasalamat kami ng kusang puso, no? Kasi every time we always have 50 or more participants. And of course, good morning to my fellow officers of sandali. Yes, merong I have a bit of technical issue. Nag-crash yung OBS ko. Anyway, the show must go on. So to the participants, thank you. To my fellow officers of ISEP Cebu chapter, thank you so much for joining us this morning. No? And I have one important announcement. It's about the upcoming mid-year convention of ISEP National. It's going to be on June 4 and 5. Now, let me remind everybody that at least your myisep.net account is activated so that you could register to the event plus the other events that we have. So let me share with you what is this portal. So this is the portal, no? So for those who are already using the portal, you can generate your COGS, you could check your points. So there are so many features now of the myisep.net portal. So I encourage everybody to keep on using myisep.net. And for those who are not yet using the myisep.net, please contact our Secretary Mel for any assistance. So again, welcome to this webinar, 5G, the new wave of connectivity. And to introduce our resource speaker this morning, I would like to call a member of the board of director of ISEP Cebu chapter to introduce our resource speaker. Let's have Engineer Glenn Pindang. Glenn?
Sir, good morning. Good morning, my fellow engineers and other participants today. Our resource speaker this morning graduated from Angeles University Foundation in Angeles City with a degree in BS Electronics and Communications Engineering in April 2012, and then passed the ACE Board licensure exam of the same year. In 2013, he joined Globe Telecom after finishing the cadetship program of the company. He is a member of the Ayala Young Leaders Alumni Association in Central Luzon since 2011, a member of the Outstanding Students of the Philippines in Region 3 since 2012, and a member of ISF Manila Chapter. He has conducted many seminars, mostly on 4G, LTE, and 5G mobile phone systems. Among his major achievements, citations, recognitions, and awards are: he was the delegate to the 2011 Ayala Young Leaders Congress organized by the Ayala Foundation Incorporated. Finished his ECE cum laude in 2012 at the Angeles University Foundation. Awarded Outstanding Student for Leadership by the Angeles University Foundation in 2012. One of the 10 outstanding students of the Philippines, Region 3 in 2012. Awarded as AEI Employee of the Year in 2017 by Globe Access Engineering and Implementation. A certified line trainer by Huawei Technologies Incorporated in 2019. And last year, he was awarded as TSSI Employee of the Year by Globe Network Planning and Engineering. Ladies and gentlemen, please help me welcome the lead for Network Technology Innovations, Engineer Derek M. Dimla. Thank you.
Hi, Derek. I think he's here. Thank you, Glenn, no, for introducing our resource speaker. Um, Derek is here. Let's just check his... Baka nagkaroon din ng konting technical issue. Sir Derek? Nandito si Derek eh.
Can you hear me now?
Yeah.
Okay, so I think I'm having
I
a
thought
problem
you
with
went abroad eh. Sorry.
So, good morning everyone. Maayong buntag sa inyong tanan. And so, welcome to our 5G seminar, no? Yeah. So, can you see my screen now?
Yes.
Is my audio clear?
Yeah. It's okay.
And great. So, I think I'm having a problem with my audio card earlier. So good morning, everyone. Thank you so much for the introduction. No? And I wanted to make this webinar interactive. No? Siguro, in the meantime, no, while we are watching in this webinar, what I wanted you to do is maybe you can just put in the chat box where you from. Kumbaga saan kayo nakikinig ngayon. No? I think some other attendees here coming from abroad. So last time I heard there were some from there were attendants from Saudi Arabia, no? Ibig sabihin, as early as 5 a.m. they're attending this webinar already. And please chat tayo dito. From Talisay, Cebu, mayang buntag sir, no? Hindi po ako Cebuano, pero there was some time na area ako dyan sa Cebu, no? And I hope you can see my screen very clear. Tama, Sir Gilles, na nakikita naman?
Yeah, we could see the title of the presentation.
Interactive. Meron din from Angeles City, meron din from Southern, later from Laguna. We are all over the Philippines.
Nationwide, so, yeah, that's the advantage of an online webinar.
Yeah, and I hope this morning session, I'm pretty sure that this the weekend that we're looking forward kasi gusto natin every weekend we wanted to be with our family, lalo and work from home, gusto natin may spend yung time natin with our family during weekends kasi pagka Monday to Fridays, no, talagang focus tayo sa work kasi naka-work from home sometimes, so we cannot even delineate or segregate yung work at saka yung yung personal life natin.
By the way, Derek, no, yeah. Our speaker 2 Saturdays ago is also here, your colleague, Cesar Harta, no? Sorry, I forgot to welcome. He's joining us this morning. Yeah.
Good morning,
Good
everyone.
morning. Good morning, Sir Hart. So, welcome
Director
to
of
our
Globe
5G.
Telecom, no? Thank you. And he was our
Yeah.
speaker two Saturdays ago. Yeah. Okay, go
Let,
ahead, Sir
let
Derek.
me connect. Let me... Nawala yung screen ko, no?
Yung ano mo na, yung magandang ano mo yung buhok mo. Ako wala na akong buhok, hindi ako pwedeng magganon.
Yeah, I'm sharing. I'll share my screen. Uh, Yan. Kita na ba ulit, sir?
Not yet. Saan ka ba ngayon? Sa Taguig or sa Pampanga?
Currently, nandito ako sa Pampanga, Sir Jude.
Okay.
Yeah, working from home.
Okay now. Okay. We
Yeah.
could see the screen again.
Okay,
Thank you.
great. So good morning everyone and welcome to our Saturday's webinar. Thank you so much ISEP Cebu for organizing this event, and I wanted really to share some insights with you with regards to our 5G network. So welcome again to people from Laguna, from Lapu-Lapu, Santa Rosa, Angeles, no? So welcome po tayong lahat. No? Please feel free to chat anything you wanted to ask me. No? As we move along naman, we will check all the chat and we will answer those immediately if you wanted to. No? Lalo na pagka may mga naisip kayo agad. So for today's discussion, we'll be talking about 5G networks. No? It's the new wave of connectivity as it was slated in our invite. No? So, ang first question natin, no, and sige, pwede tayo mag-chat sa chat box or if you wanted to unmute yourself, just feel free, no? Pag sinanong natin, ano ba yung 5G, no? Kasi tatanong tayo, ba ibig sabihin ng 5G? Pagka nag-search tayo sa Google, or if you use your phones to check online, what is 5G? It talks about artificial intelligence, it talks about speed, it talks about application, it talks about IoT, it talks about latency, and there are so many things na pwede mong i-relate to 5G, no? Kahit nga minsan, yung mga ibang myths about 5G is being shown in your search bar. So siguro, no, to give you then, or to give you a chance, so tingin nyo, ano kaya sa tingin nyo ang 5G? Sige, you can chat, no? While we are doing this discussion. Ano kaya sa tingin nyo ang 5G for you? Okay? So, now, ano ba yung 5G now? We know that there are other technologies that are out there. We have the Wi-Fi, we have the 4G, we have ano ba yung mga connectivity natin? We have the fiber, no? And everything else. Ngayon, 5G being one of the newest and hottest technology in the market, it talks about speed, no? Bakit? Because, no, all of our big telco that are in the country now are already marketing this at, sabi niya, experience fastest non-stop 5G data now in NCR. And are you 5G ready? Sabi naman ng Globe, no? Tapos I think dito is also catching up in, marketing their 5G connectivity, no? And if there are some people from this telco, meron tayong mga people from Globe, meron tayong people from Smart, meron tayong people from dito. In this session, we will be talking about 5G in general, no? 5G as a technology tayo dito. We'll not be talking about the promos, the plans, the serviceability, the connectivity, and so. But what we wanted to do for you to understand, lalo na tayong mga tayong ISEP, tayong mga electronics engineers, tayong mga engineers, you wanted to know the technology, what is ahead of us, no? Kaya yung pag-uusapan natin ngayon. Pero just for us to realize what 5G is, yun lang, no? Meron tayong mga services that are being offered now anywhere in the Philippines. Yan yung mga ating mga partners or mga telco natin, sila Globe, sila Smart, and sila dito. Okay, I hope that's clear. Now, ano ba talaga yung 5G? How do we realize 5G now? So that's the main question that we wanted you to experience, no? Lalo na yung mga ating mga kababayan that are from different parts of the world, no? I think they're also rolling out 5G and somehow they're experiencing as well ano ba yung 5G. Now, 5G talks about mainly in speed, but there are other capabilities of 5G, but for today's discussion, we'll be focusing on speed. But before we move to discussing how 5G will change, will transform its speed, maybe we could just run through these main three points, no? We have to discuss first yung principles of communication, no? Yung ating mga standards, at saka syempre yung intro to 5G. And then we'll be talking about yung speed natin. So I hope that's clear as well, no? That's a pattern of today's discussion or this morning session. talking about principles of communication, alam naman natin that whenever we wanted to say something, no, we wanted to express it. And when we wanted to express it, we will send this one or we will say this one to the people who we think should be receiving the message. No? Kaya meron tayo sa principles of communication, meron tayong idea ng sending and receiving. So, basic yan. Ibig sabihin, kung nandiyan yung nanay mo, nandiyan yung tatay mo, nandiyan yung kapatid mo, nandiyan yung si crush mo, if you wanted to say something direct sa kanila at katabi mo siya, you can say it. Tama? Pwede mo sabihin through words, through gestures, no? And that's a form of communication. Now, if you send that message, nakatabi mo lang siya, then it's okay. Problem is, when you move towards a farther distance, that's the problem. No, nagkakaroon tayo ng distance barrier na tinatawag natin. Because you cannot say or you cannot shout a message, no, and the people who's going to receive the message is 1 kilometer away from you. Then there must be a way or means on how to communicate that message to that person. Let's say, if you wanted to send some help from kilometers away, then you might be probably firing up a smoke so that you will be able to send message na, oh, nandito ako sa area na to, or there's a problem in this area. And then if you want to alert people that the king is coming, no, or people are entering the kingdom, kings are entering the kingdoms, guests are entering the kingdom, then you might be rolling out some drums, diba? Pwede yan. Or if you see some emergency instances, if you want to go forward, then you can blow a horn. No? Yan yung mga iba nating mga ways of communicating. And ito yung mga maganda pa, no? Yung mga dove natin or yung tinatawag nilang homing pigeons wherein they can train pigeons to move away from a very far area and then papadala na yung message so that it can come back home. No? Sir Julius, just checking out lang. No? Is my audio still clear? No interruption so far?
No problem. It's loud and
Great.
clear.
So yan, no? Favorite kong part na to because, you know, people have ways on, you know, developing the way they communicate. No, kaya nga sabi nga nila, di ba? Ano, invention is, or necessity is mother of invention, di ba? So ngayon, tignan natin ngayon, these homing pigeons can go back home to send or carry a message. Pero ito yung pinaka-favorite ko, si Fidey Fides or Fidey Fides, no? Siya yung nag-travel from Marathon to Athens to deliver the message that Greek has won over the war. So, kaya lang, no, sadly lang, Fidey Fides, as he was known to be a hero, died after running 320 kilometers. Kasi, kahit naman ikaw tumakbo ng 320 kilometers, di ba? Talagang you will be exhausted. But you know, the good thing about this one, people are doing extreme athleticism and people are already adopting this way of living as well. People are running 320 kilometers, running 1,000 kilometers. People even, some athletes, no, would go 3,000 kilometers. That's what we call the transcendence. People from Japan as well are running 42 kilometers for 1,000 days, no? And a lot more to bring up a message. So imagine, no, ganun nag-evolve yung communication. Then we started sending message through these ways or through these means because we wanted to overcome that distance barrier. Okay? So send message, receive, etc. Now, communication, alam naman natin, no? Dahil nga mag-send ka ng message, mag-receive ka ng message, is there a way to link up between a sender and a receiver? For these 4 types of communication or these means, wala tayong link between the two. We're just using kung ano yung available, which is the environment, no? Pwede kang tumakbo by land, pwede kang tumakbo by using a courier, using a horse, no? Or you can even send pigeon over the air, drum beats, sound traveling over the air, no? Smoke, light messages from over the air. So now, to overcome that distance pala, there are ways, no, to send message. Now, yun nga, nagkaroon tayo ng evolution na itinry natin yan nung bata tayo. Siguro, yung may mga bata siguro dito na no, Sir Julius, kasi I graduated, sabi nga sa introduction, 2012, no? Baka may mga nag-graduate dito 2020 or 2021 for graduation yun. Baka medyo bata na sila, hindi na experience yung maglagay ng PC between 2 cans and then really move communicate, no, at a limited distance. Yan ang mga natin. Now, after the connecting, natutunan natin yung pag-send ng data through Morse code, through communication, telephone systems, by Graham Bell, no? We evolved, no, from sending just message nagkaroon tayo ng idea that we can send not only message but even data. Kaya nagkaroon tayo ng tinatawag na digital systems or what we call digitalization, quantization, no? And so on. Ang sasabi natin dito is that we are now able to communicate those analog signals into a digital one. Pag sabi natin digital, ibig sabihin 1 and 0 lang yan. And when we're talking about 1 and 0s, meron tayong tinatawag na bits and bytes. No? I hope no, na-remind tayo dun sa ating principles of communication here. Meron tayong tinatawag na MB at saka meron tayong MB din with capital B. The difference is, anyone from the group, anong pinagkaiba ng capital B at saka ng small b? Small b would pertain to bits and capital B would mean bytes. At ano yung equivalent nito? 1 byte is equivalent to how many bits? Sige nga, pa-check nga. Yun! So maraming salamat, Sir Geno. No? Yan, and it's a good friend of mine as well, si Sir Geno from Cebu. No, that's correct. So there is a difference between bits and bytes, and that is 8 bits is equivalent to 1 byte. So meaning, pag sinabi na MB with capital B, it talks about volume. And for data transmission, digitalization, transferring over the air is being measured in bits. Okay, bakit bits? Mamaya pag-uusapan natin yan, no? Magandang pag-usapan yung bits. Bakit nga ba bits? Bakit hindi na lang mega bytes? No? Bakit kaya? Magandang pag-usapan yan, no? So, mayroon naglabas dati ng news, no, that a certain telco would have a certain speed that's ranging from 100 Mbps daw. So mistakenly, nalagay dun sa publication that is a capital B, and I think it was tinolak din nila yun because there might be some confusion, no? Kasi bytes would means 8 bits. So 1 BPS would mean 1 bit talaga over 1 second. But 1 byte per second, that would mean 8 bits per second. So there might be some confusion. Ibig sabihin, kung meron kang speed that you're committing of 100 MB with a capital B per second, so that would mean 800 megabits per second, no? Just for the sake of conversion. Tandaan natin yan because that's critical when it comes to the later discussion. Yan, no? Okay. So, alam naman natin that bits and bytes, no, are very critical now, lalo na sa atin ngayon. Actually, even nga, no, we are currently engaged in a Zoom meeting or in a webinar, in a digital or in a virtual setup. We are using certain applications, and applications would require millions and millions and millions of bits. Just like I'm talking right now, my voice, which is an analog signal, it's being converted by my laptop into a digital signal and being transmitted over the air and being somehow managed by what we call server of a particular application, and then it's being converted back into something that I can see or something that I can understand, like audio, video, no, and so on. So, paano ba nag-work ang internet now for everybody to get on board that what's happening in the internet now? Of course, you should start with an application. An application would require a user to transact with whatever application he has in his laptop, in his device, in whatever communication tool he's using. Now, this user can connect directly to site, or it can use a router or a modem to connect to the internet. No, that's easy as 1, 2, 3. Kaya pagdating mo sa bahay, no, kaya minsan even yung kapitbahay mo kayang kumonekta sa wifi mo kasi it's being broadcasted over the air. So, yung kapitbahay mo ngayon, kumukonect siya sa modem mo at nakakapag-Facebook siya. At alam naman natin that ISP4 network, like yung nga nabanggit natin sa introduction natin, may 3 players dito. And there are even a lot more. No? Meron tayong mga Converge, baka there are people who are working here in Converge, no? From Globe, from Smart, and all other telco which offers internet service. Ang ISP would mean internet service provider. Ito yung mga talagang nagbibigay ng internet access sa atin. Can be direct internet, can be broadband solution, etc. So from the ISP core network, it will now go to an application server which is allowed by the core network kung nag-offer sila ng ganung services. Like, let's say kung Netflix man yan, no, dapat mayroong subscription si ISP core network to the application server of Netflix, let's say. Or yung kanyang link, no? Rather subscription, meron siyang link going to that application server para makakuha siya ng information coming from that application server and will be able to watch from your application. So basic application, application, user, modem, ISP, application server, and then back to you. Okay? Kaya nakakapanood ng internet. Now, ano din tayo, babalik din tayo sa communication. Siyempre, alam naman natin, that's a one-sided way of thing, no? Nagda-download ka, nanonood ka, nag-games ka. But people now have become, somehow responsive to the call of our generation, which is communicating instantaneously. When we say instantaneously, kahit kailan mo gusto, maisip mo maisip mo yung kaibigan mo na, kumakain ka, nabalunan ka, tapos naalala ko text ko nga siya, or tawagan ko nga siya, or i-video chat ko nga siya. Things have changed, no? We wanted to see them, we wanted to be somehow virtually and physical, you see them on your screen, no? Kahit na alam natin na they're virtual, pero as soon as you see their pictures, nakakatuwa na nakita natin sila. Updated tayo. Unlike before, my dad used to work abroad, and the only way to communicate them is by loading your phone, no? Shucks, ang tanda ko na. Gamit pa na is Bosch na phone, no? You have to load it. I think 100 peso for 7 to 8 minutes, no? I can hardly remember. So, huwag tumawag ka. Sir Julius, nabulan mo ba yun? Yung mag-load ka tapos tatawag ka na overseas?
Hindi, yung nabutan ko yung may party line pa.
Thanks so much, Julius, for sharing that, no? I believe...
Older than that. Older than that.
Older than that, yeah. Age comes with beauty talaga. So, those people, might probably some millennials today will be confused, what were those things. But, yun nga, same pa din, kung tatawag ka sa kaibigan mo through Messenger, or through a certain application, or OTT, WhatsApp, Viber, whatever application you have, or Zoom, you can actually directly call him as long as you have the internet and as long as you have a subscription to that particular application. Okay? So yan. And some people, meron ako nabasa lang, and I think baka aware din kayo. Sabi nila si Messenger daw ay hindi encrypted up until 2023, yung mga data nila. So if you are sharing some information through Messenger, just be careful lang. Or check na lang with updates ng Messenger kung ano yung mga encryption na protocol na ina-encode nila on the Messenger. Now, what's communication? Maintindihan naman natin, kasi 5G networks nga ito, new ways of connectivity. What's the difference between the existing one? Meron tayong mga Wi-Fi, meron tayong mga fiber, etc. But to make you understand how 5G works, I want you to understand as well that it started with 2G, 3G, and 4G. Basic lang, pag wala ka sa loob ng coverage signal ng isang tower, hindi ka makakasend ng data to a channel. Okay? That's a basic requirement. Pag wala ka sa loob ng signal, because you need to link up or to create what we call the barrier between the network or the tower na nakikita ninyo to the phone. You need to build up a link between the two, Kung hindi ka niya makita, hindi ka niya marinig, then definitely it will drop you off, which is yung magiging panic experience mo because you are outside the coverage. If you are within the coverage area, and meron kang 5G network, meron ka ding 5G device, then definitely you would be able to link up that there. Ganyan sinasabi natin. Ngayon, we know that 5G is a wireless communication. It's a new wave of connectivity. By the way, 5G means G would mean generation. May pag-usapan din natin yan. The only way to communicate, it's either you have a modem and to communicate to the tower, or if you have a phone that's 5G capable, a modem that's 5G capable, you can directly connect to towers that has 5G services. As long as you have a particular subscription to those telco services or telco that offers those services. So, kailangan mo ng 5G device and 5G network to work. Now, ang pag-usapan natin, alam natin that communication, kagaya yung pinag-usapan natin kanina, there's a distance in between, which is your left, sender and receiver on the other side. I'm not sure if I can annotate here. So, dito meron tayong sender, dito meron tayong receiver. And yung link between that connects the device and the network is what we call the air interface technology. And that's where 5G is, or really has transformed the way we communicate. Because they're opening new ways of channels, technology, and key radio functions na pag-usapan natin later on. How to erase this one? Here, all drawings. Okay, there you go. So, pag-usapan natin itong link na to.
Puli-puli si
I hope that's clear as well. So, let's imagine muna. Kahit ganapin na usapan natin, link, no? Link. Pero para makita natin yung papaano nag-link yung ating communication network. Let's try to imagine lang itong ating lagayan, a container, no? With a certain faucet and a basin or a pail, no? There's a link in between. The only way for you to transfer the volume of water from a certain container to another container is by opening the faucet. And opening the faucet would allow you, or we will allow the flow, no, to get you from the container, from this tap or ano man yan, no, lagay ng tubig going to your basin or to your pail. Now, imagine, every time na binubuksan mo yan, syempre, tumutulo talaga yan, no? At alam naman natin na because of the gravity, because of the pressure, na talagang napupuno yung ating lagayan. At a certain point na magiging purely puno na talaga siya. So the question now is, if the tank has a 20-liter capacity initially, meron daw siyang 20 liters, and the bucket was filled up full, napuno daw yung ating bucket at 5 seconds, the remaining water in the tank now is 15 liter. 15 liters na lang. So, ano daw yung rate of water transfer? Meron ba tayong sasagot dito? Baka may sumagot dito. Makikita ba natin?
Yes, klaro naman. Ano, di ba physics na yun? Grabe ka naman.
Ano?
Bagsak ako
Sir?
sa physics eh.
Hindi sir, may calculations lang po.
Rate yan, you're talking about rate, di ba?
Yes.
Ah.
So baka ito, basic na, nagana daw tayo, meron daw tayong tangke na tubig na meron siyang 20 liters, no? Tapos pinuno natin yung bucket natin kasi magdidilig tayo ng halaman or ano bang gagawin natin, maghugas tayo ng sasakyan, no? Or magka-car wash tayo. Kailangan natin ng 5 liters or ng certain bucket full of water para mabuhusan natin yung sasakyan natin. So meron daw remaining water na 15 liters. Ano daw kaya yung rate of transfer natin? Is there anyone?
Kung sinong makasagot, one free webinar, next webinar.
Uy, grabe naman sir, may sumagot na sir, si Jarvis Pua.
Oh, sige. Anong sagot? Jarvis. Paki-on sa mic.
Si Jarvis, anong sagot Jarvis?
1 liter per second po, sir.
1 liter per second, tama ba yung sagot niya? So Jarvis, are you using Are you using GCash?
Hindi, free webinar lang.
Hindi, ako sir, magbibigay ako ng GCash.
Okay, ibang premium pa yun. Grabe ka naman. Awash in cash yung Gcash mo.
Oh, I can provide GCash. Basta GCash.
Sir, divide mo 3 yan. Tatlo lang ka-answer dyan. I-divide mo ng 3.
Ay, hindi yun.
Siyempre yung una lang. Yan yung
Wala na yan si Carl. Hindi yan pwede. Official na yan.
So si Jarvis po, yung using yung GCash from me. So, pakipiyam na lang si Sir Julius on your number, no? Ang tamang sagot ay, okay, so wala tayong sagot. So compute lang natin. No, 20 liters after 5 seconds, naging siyang 15 liters. So ang bucket capacity natin will be 5 liters. Direct calculation, walang involved na higher mathematics, walang differential equations dito. So rate of transfer lang natin would be the bucket full capacity divided by the time to fill it up. So 5 liters, tapos 5 seconds naman daw, as mentioned by the problem, it's 1 liter per second or 1,000 milliliters per second.
Sir Derek, yung
Yes,
price
po.
niya Gcash so ibigay na natin yung free webinar sa mga ibang questions.
Okay. Okay lang sir.
Meron pang free webinar. Bahala ka na kung anong question mo. Questionin mo kung ano yung 6G.
Sige sir. Tawa natin yan. Okay. So thank you so much sir.
Paki-chat sa number mo na Gcash. May Gcash kaya si Jervis? Sino po bang isiin na walang Gcash? Baka Paymaya, hindi.
Oo nga, no, baka yung, sir, kalaban. Yeah, but just let us know,
Ay,
Jarvis.
naku, wala siyang Gcash. Nag-chat
Wala
siya.
siyang GCash.
Sa akin
Ano
na.
na lang, sa kanya na lang yung free webinar. So,
Okay, sir.
next question mo na lang later on para makikinig sila.
Yeah, sige sir, okay yan.
Baka yung Gcash mo, 6 digits yun, ha?
Yeah. So, yeah, no? So, thank you so much for listening very closely to this problem. You know,
So, free webinar sa kanya, ha? Mel, pakinote down. Free webinar kay Jervis Buwa, hindi Gcash, kasi wala siyang Gcash eh.
wala siyang Gcash.
So, naka-reserve yung premyo ni Sir Derek. Sige, sir, go
Yeah,
ahead. Baka
sige.
next question mo, may ano na yan, ha? Differential equation.
Ano lang to, for fun yung webinar natin to. So, I
Ay,
try to make it
pangalanan to.
as simple as possible with you guys. So, ayan, no? Checking my time, so 9:38. So, I'm still on track. Now, pinakita ko lang tong part na to, it's because I wanted you to understand yung transfer, no? Kasi, this is where 5G, no? This is where bits per second, na kung natawag natin, no? Pagka nag-apply tayo ng line, nag-apply tayo ng certain broadband application, mga internet services, let's say, they offer you 100 Mbps, that would mean 100 megabits per second. Meaning, ang transfer rate niya, they can send over a channel of 100 millions of bits kada segundo. So, kagaya nito, ibig sabihin, pagka meron kang rate na 1,000 milliliter per second, ibig sabihin, kaya magpuno ng isang lagayan ng Coke kada segundo. So, imagine, if you will be given a 1 minute, no? 1 minute time to fill up whatever you can, how many bottles naman? So, that would mean 60 liters of, or 60 bottles, no? With 1 liter capacity. So, ganun yung ibig sabihin niya. Though we have a lot of calculation later on, no? That's totally, I'll try to make you understand on that. So now, alam naman natin that, what is communication? This is not something that we cannot see, no? It's something that we cannot hear, it is something that we cannot smell, no? You can't even taste it. You cannot touch wireless communication, but you can actually measure it through your device by your day-to-day application. Di ba? Pagka wala tayong internet connection, ang unang gagawin natin, titignan natin yung modem, or kung tamad kang mag-check ng modem, what you're gonna do is go to speed test and then test the connectivity, di ba? Yun yung pinaka-base na ginagawa natin. And then pag nakita mo nag-server error, automatically, ay walang internet, no? Kainis naman tong brand X na to because nasira yung aking pag manonood ng Netflix or nasira yung pakikinig ko ng webinar sa ICEP Cebu, no? Magagalit tayo kasi alam mo yun, hindi na we are subscribed to a certain service and hindi natin siya ma-experience, but you cannot even see it. But you can always have a ways to measure. So yeah, no? Pag meron kayong mga iPhone, you can just dial asterisk 3001, number sign 12345, number sign asterisk, and then you click dial. Makikita niyo yung mga functions na yan because you can see that the radio properties, no, are being broadcasted over the air. Same with all other technologies, no, mapa-TV man yan, mapa-radio man yan, kung ano mang broadcast yan, pagka binabato yun over there, there's a way to measure it. No? You can use scanners, you can use your phone, you can use your radio receivers, or telecommunication devices. No? And kung may mga attendees tayo dito coming from those industries, mga testings and measurements, no? Thank you sa inyo because you guys are developing such tools for us to optimize the network and make sure that the service that we offer to our customers are the utmost service that we can give them. No? And if you're using Samsung, asterisk number sign 0011 and number sign, these are USSD code. No? Nabas siya yung mga properties natin. And for 5G, no, some of the measurements na pwede natin makita. So, yan, makita natin, there's a 5G signal coming here, and then yung mga measurements, nandyan po yung mga yan. So you can actually measure those things. And if you are from the RF or radio frequency engineer, you would be able to understand these things. Okay, so what is 5G ba talaga? No? 5G more than a technology, it is a standard. Okay, lagi natin tandaan yun. Since we started 2G, 3G, 4G, 4.5G, 4.75G, LTE-A, LTE, ano ba yun? LTE-A, LTE Plus, no? And all other cellular communication, yan ay pasok po sa ating tinatawag na 3GPP standard. Okay? At ang 3GPP standard ay composition ng ating radio access networks. Meron tayong core terminals, which is the CT. We have the system services and aspects. Meaning itong tatlong to nag-uusap yan para maglabas ng ating tinatawag na technical reports and specifications. Meaning, gumagawa sila ng mga technical documents for the network operator, for the system or the governing body of a particular country or region, and device manufacturer to align na ito ang gagawin nating standard for 5G, which everyone should comply by any means. Ano mangyayari pag hindi ka nag-comply? Then you would not be able to sell your services. That happened, no? Just a simple question, simple story lang. I'm not sure if it's in my next slide. It's what we call the OTSA or Open Trial Systems, no? Alliance. Pag nag-open trial ka, meaning you're not setting up a standard. You are going or you are moving away from what's set or what's the standard to somehow madaliin mo yung commercialization. But the problem with that, kung wala kang standard na gagamitin or you will create your own standard, then that's really, really hard to market. Yun yung pinaka-problema doon. That's why this 3GPP puts up everything in plate. Yun yung gagamitin ng network, yun yung gagamitin ng system, yun din ang gagamitin ng device for them to comply and agree so that they can sell the services, the end-to-end architecture for people to experience. Okay? Clear yun ha? So, ibig sabihin, pagka mayroon nag-ooperate dyan that is outside the 3GPP, we can either see them going down of the market because there's no demands on it. Kasi, gusto mo ba na meron kang phone na hindi papasok sa existing service na ginagamit? Then, that's not the thing that we wanted to happen. So, ngayon, lahat dapat ay 3GPP compliant. So 5G sa 3GPP compliant, it's a global initiative wherein they set up the standards by sending and releasing technical reports and specification. If you wanted to know more about 3GPP, you can just click this or you can just go directly type 3GPP and then you go to 3gpp.org. About 3GPP, you will be able to understand. So Dito, Globe, and Smart are also compliant to 3GPP, no? And of course, the device manufacturer like Samsung, Apple, Huawei, Oppo, Vivo, and all other devices, no, nagko-compliance sa 3GPP para mas madaling ibenta yung device. Sabihin niya na, this device is approved by NTC and it aligns with the frequencies that being allocated by the WRC or by the FTC, no, and the Federal Telecommunication Commission. Pinag-uusapan nila yan so that it will be able to market or madaling ipa-experience sa mga users natin. And that's why 5G is here in the Philippines because of this compliance we've done with 3GPP. Okay? I hope that's clear, no? And even sa mga nagtatrabaho abroad, no, na focused on the cellular communication, I think if you can share some insights on the chat, no? And if you're working particularly on contracts, on licensing, no? Alam ko na dapat nag-agree tayo with the 3GPP compliance. Minsan, if you have a partners or vendors, no, you talk to, yan yung unang hingin nyo sa kanila. Ano yung compliance nyo with the 3GPP? Because there are some other 3GPP non-compliant features that may still be applied, no, as long as it adds benefit to the network. But we have to declare those things. Now, 3GPP, sabi ko nga kanina, no, ito siya. Okay? Ito yung mga organization na nakapaloob dyan. Yan, si ATIS, ARIB, and other international organization. No? Using the technical specifications group, ayan si RAN, si Radio Access Network. Ibig sabihin nyo, ito yung mga ginagamit natin on-site, mga systems and services for terminals and networks and terminals. Yan, pinag-usapan nila yan. Now, tingnan lang natin dito some a little bit of introduction on how 5G and ITU sa Telecommunication Union, kung makikita natin dito, ITU is a separate entity from 3GPP, no? But they have this PCG or what we call the Project Coordination Group para mag-usap sila doon ng mga kanilang standard. That's why on the next slide, you will see that there is this IMT vision to have our ITU or IMT 2020 5G. So they envision to have specifications by 2020, apparently 3GPP being fast, being in the industry for almost long time, no, nakapag-release sila ng 5G study in 2016. And they were able to release their initial technical specifications as early as 2017. So ikita nyo, there's a three-year advanced study that's conducted or that was conducted by the 3GPP as compared to ITU. Ito yung kwentong bayan niya. No? Mayroong vision si ITU to have the specification to be released by 2020, kaya tinawag siyang IMT 2020 vision. But apparently, 3GPP, again, yun nga, dahil nga sa expertise nila on the cellular technology, and with these 8 groups coming in, at saka very structured yung creation nila ng mga specification, they were able to release a 3GPP 5G standard as early as 2017. Sir Julius, okay pa ako, no? Clear pa din naman, just checking on lang.
Yeah, right, na ano lang ako, kasi this is my first time to hear about 3GPP. All the while, it's actually I was thinking about ITU. Eh.
Yeah, so at least learn itong
Di ba
3G.
ITU is a UN attached agency?
Yes, sir.
Ah,
It's ano, International Telecommunications Union, no?
Union. Yeah, right. So we're still good.
Okay, great, sir. So now, no, after we've learned about 5G, baka it's now time to identify the objective. Ang dami ko nang kinwenta tapos yun lang ako naglagay ng objective, no? By the end of the session, you will learn how to calculate theoretical speed of 5G. The idea is here. Gusto ko maintindihan natin that 5G is a new wave of connectivity, and not because it's 5G, but because it has some special features. It has a special or specific na structure that we are using that's way ahead the existing cellular network, which is LTE, LTE-A, LTE plus, no, etc. So yung objective natin, no, at the end of it, matuto natin paano calculate yung theoretical speed of 5G. So because speed of 5G is the easiest way to validate using our phone. No? Kung may mga 5G capable phones na kayo and you are registered to Globe, registered to particular service, no, in the country, no, you'll be able to get speeds of 5G. And the cellular technology we are latched on to 5G is really 5G. Again, 5G is 5G. It will be easier for us to understand or to share with our friends, so what is true about 5G. I encourage everyone, lalo na how many people are we here? We have 83, Sir Julius, napakadayo po ng participants dito. It's a good audience, it's a big audience, touching you on this area to understand what technology really is, no? Mas madali sa atin na intindihin or bahagi or share with our friends that this is the technology, no? And alam natin that we have to accept it that with the access to the technology, access to communication, access to information, it bears or it comes along with challenges. Some of it yun nga, pagpapalaganap ng fake news, no? We wanted you to understand what is the truth about the technology. No, alam natin, gusto natin what is true. Kaya we're pursuing these seminars. We're going to studies, no? Pinag-aaralan natin yan for us to even understand what's inside the technology. And alam ko madami sa inyo are technologists or hobbies talaga. No? Alam natin nag-aaral talaga kayo. Kaya nandito kayo sa ating ICEP Cebu webinar series. No? And thanks again to ICEP Cebu for putting this. Now, speed. Pag kinalculate natin ang speed ng ating 5G, actually started with even LTE, 2G, 3G, meron tayong ganyan. Subcarrier, symbols, TTI modulation, coding rates, data plus data header, TDD. Actually boring, no? Kung tinignan natin, napaka-boring naman ng basic na calculation. But lahat ng pag-usapan, lahat ng 5G na pag-usapan natin, key range of features, dyan natin pag-usapan. Because, this part, we'll be talking about the frame structure of 5G. Modulation and coding rate, these are modulation coding scheme. Bakit pagka linalakasan mo yung boses mo, mas nagiging maganda yung dating ng signal as compared dun sa napakahina ng boses mo. There's something to do about the modulation, changing the power, changing the phase, changing the yung time, di ba? So makikita natin, or phase, no? Phase pala ang term. So changing frequency, phase, and amplitude. So alam natin yan, modulation plays a big part in communication systems. Allocation, alam naman natin, may mga headers tayo nalagay. And then customization, in terms of, flexible na ang ating mga networks ngayon, you can actually configure. And even sometimes, we can go virtual na, no? And syempre, may tinatawag na antenna technique. Antenna technique, ito yung lumalabas sa ating mga antena. Now, just to talk even more about this, pag-usapan natin sa ating frame structure would be the bandwidth. Siguro, familiar naman tayo lahat dyan. Pag sinabi natin bandwidth, pag sinabi natin time, pag sinabi natin schedule. And when it comes to digital systems, meron tayong mga clocking na tinutukoy, no? For modulation, pag-usapan natin ng konti yung constellation. Familiar pa ba kayo dyan? Sa digits, no? How 1 and 0s are being transferred over the channel. Noise, error, 3GPP standard, yung the rest. Pag-usapan din natin yan kung ano ba yung nirelease ni 3GPP dyan. I know it's a little bit academic, Sir Julius, but please bear with me because this is the foundation of 5G. So what's the 5G? Sorry, 5G is boring, no? But you have to bear with me. But to understand the real 5G is, no, you have to bear with me. And I think this is the purpose of why we are putting a lot of webinars. Ang kagandahan lang dito kasi, no, pag nakinig ka kasi ng webinar sa ibang bansa, English yan. No? And you know, I'm not sure if we have foreigners here. Meron ba tayong mga foreigners dito, Sir Julius? Sana wala, no, kasi gusto kong mapag-usapan natin to in Filipino or in Tagalog para sa maintindihan talaga natin, because that's the real intention of this presentation. Wala sir, no?
Paranger.
Yeah, wala naman. So if there are foreigners in the webinar, you can just click auto caption, no? Makikita nyo, there will be subtitle underneath your screen. Yeah. Anyway, so 5G features its frame structure. So pag sinabi natin frame structure, no, we'll be talking about 5G being a wireless technology. Kailangan kahit naman anong anything that carries anything, no? Any device or any carrier that carries anything, meron siyang tinatawag na frame. Halimbawa, kung bibili ka ng sasakyan, a 7-seater SUV as compared to 5-seater SUV as compared to a bus as compared to an ambulance, no, magkakaiba sila ng capacity because they have different frames. So that's the basic analogy that I can share with you. And ang bus ay meron siyang 50 capacity, no? And it's bigger. And of course, the frame structure is also frequency-based. No? Frequency has bandwidth. Frequency is cycles per second. Natatandaan mo ba yan, yung mga frequency natin? Na pag sinabing 1, o pag sinabing 50 kilohertz, no? Kilohertz, hertz is not plural, but rather it's named after hertz. No? Even 1 hertz is still hertz. No? Pero, no, it really hurts. No, basta, frequency is about cycles per second. And frequency has wavelength, alam natin yan. Bandwidth is difference between upper and lower frequency. And you know, 5G, as we understand later on, it will have a shorter coverage kasi it plays a vital classification in our spectrum. Meron siyang assigned spectrum. Kaya kanina na pina-intindi ko sa inyo yung 3GPP because may mga din-design talaga sa ng specific frequency para sa every technology. Kaya hindi ka pwedeng mag-overlap with other frequencies because all the frequencies are assigned already unless it's unlicensed. No? Nagkaiba. Now, syempre, kung mababa ang coverage natin with certain techniques like putting up the tower, no? Pag pinataasan mo yung tower, may help, of course. It can reach farther coverage kasi, di ba, pagka meron kang megaphone at nasa baba ka lang, better is you go up a stage or go up on a stage or go to certain area that's higher, and then you can even increase your power going to the subscribers or to the listeners. And of course, adding more towers, no? Kaya I think there is this rally coming from the telco as mandated by our president with the Bayanihan Act 2, no, to fast track really yung ating rollout in terms of data and internet services because this is the lifeline of our situation now. Why? Because internet now is life. Without internet, how can you work? Without internet, how can you do research from your home? How can you attend a class? How can you join a webinar that's being conducted by ICEP Cebu without internet? So lifeline na talaga ang ating internet. Now, there's some misconception about 5G. So, ang ating 5 gigahertz na coming from your Wi-Fi router is not a 5G signal. It is a 5 gigahertz of frequency and not a 5G technology. 5G means, by the way, is generation. Kaya pag bumalik tayo dun sa atin at 3GP kanina, it's second generation, third generation, fourth generation, and fifth generation. So 2G, 3G, 4G, 5G means generation. And every generation, there is an improvement on the existing technology. That's why we're talking about 5G now, because there are a lot of improvements when it comes to its generation. So now, hindi ito ang 5 gigahertz na mababasa ng iyong phone, no? Via Wi-Fi signal. Hindi siya yon, okay? So pag nakalagay doon, configure 5G parameters, no, hindi po yan 5G, okay? It's a 5 gigahertz. Magkaiba po yun. And of course, hindi rin ito yung 5G na iniinom natin, no? Tatanggal daw yung anong anik-anik mo dyan. So hindi po yan. Now, for the frame structure, sabi nga kanina, no, we'll be talking about frequency. Frequency, as we know, as we go on the right side, no, we have increasing wavelength because the frequency is going down from, let's say, 1 kilohertz going to 500 hertz, no, 200 hertz to 0 hertz. So there's the wavelengths becoming bigger and bigger or longer and longer. And habang tumataas naman yung frequency, there's yung mga waves natin nagiging maliit, no? Because of the formula, alam natin yung wavelength formula, lambda is equivalent to C over F, which is C is the speed of light, which is calculated at 299,792,458 meters per second, no? Yan. So F naman is the frequency na gagamitin mo. So if you're using a certain frequency at a lower rate, let's say 700 or 500 hertz, no? That's a way longer as compared to 35 kilohertz of frequency. Okay? So, makikita natin yan. Later, pag-usapan din natin sa frequency yan. So, basically, you can calculate, no, kung ano yung wavelength natin using this formula. Okay. Now, frame structure, we'll be talking about as well the bandwidth. No? Bandwidth, alam naman natin, the wider the bandwidth, the higher bits are transferred over a period of later earlier kanina, no, we were able to check then yung ating pipe, no. Ano yung kanina yung pipe natin, si Jarvis Pua, we're able to answer that, so 1 liter per second. What if I double up the pipe, no? Paano kung doblein ko yung taba ng pipe ko? And ano yung ating mga mathematical correlation? One, I can fill up the bucket in 2.5 seconds, no? Mas mabilis ko siya ma-fill up. Or if I have a bigger capacity, then in 5 seconds time, I would be able to fill up 2 buckets naman, no? Or 10 liters of water. Maalala niyo yun, no? Yung ating pinag-uusapan. So, I hope nakuha pa natin yun, no? Next, frame structure pa din. Alam naman natin that the wider the bandwidth, by the way pala, no? Familiar naman tayo sa pag-calculate ng frequency or ng bandwidth natin. Bandwidth would be equivalent to F2 minus F1. So ito yung taba ng bandwidth at a frequency domain. Ito ay frequency domain na hindi po siya time domain. Ito ay time domain. This one is a frequency domain, meaning nasa spectrum tayo. And yung between two frequency, you'll be able to check the wide or the width of the bandwidth or of the band. If you minus yung ating frequency at F2, minus mo yung F1 natin. So ito yung kanyang tinatawag na bandwidth. Okay? At alam naman natin, no, kagaya ng pinakita natin kanina, that bandwidth is relative to the wavelength. So pagka mas mababa ang iyong frequency, mas mahaba ang iyong wavelength. So pagka tumataas naman ang iyong frequency, no, this is 3 kHz, the wavelength would be from point to point. So this one would be your new wavelength. Okay? So sasabi lang natin would be this one, ito yung wavelength ng ating 1 Hz. So 2 Hz ito yung kanyang wavelength, and this is the wavelength of a 3 Hz of bandwidth. Okay, so mas maliit, lumiliit yung kanyang wavelength, the higher the frequency it gets. Okay, mamaya may relate din yan. So far, it's time check, it's 10 a.m. So I hope you guys are still okay in there. If you are, no, you can just click thumbs up in the group chat so that I can see you. Yan. So, bandwidth pa din, lalagayan daw ng mga bits per second. So, when we go to LTE, just a basic comparison, no? 5G has a bigger bandwidth, which we will see later on. But for us to understand, no, kung ano yung pwede nating ilagay dyan, with bigger capacity kasi mas madami yung bits na pwede mong ilagay over a certain channel. Okay? So that's what we call the capacity. Spectral efficiency is different. We will talk about that later. No, baka may mga questions kayo on that. This one, so if we're comparing bits per bits lang, no, with bigger capacity, of course, mas malaki talaga ang malalagay mo ng tubig. Kagaya nung sabi natin kanina on the pipe, no, pagka tinataba ko siya ng times 2, I could either reduce the time or I can fill up 2 buckets in same period, just like the 1 liter per second rate. No? But for further understanding, no, efficiency, these are not even bits, these are symbols. Kasi symbols would be able to house bits. Pag-usapan natin yan later on. Pero for this presentation, for this slide, no, what I can tell you is that with bigger capacity, as Shannon, sinabi nga yan ni Shannon, no, the bigger the bandwidth, no, the bigger the capacity there is. So, ibig sabihin, the bigger the capacity, the bigger number of bits I can transfer over the same period. So, bago ito, 5 seconds, no, it is in the time domain. Makikita natin that how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 bits ang kaya kong ipanala within 5 seconds with the same size of symbols ng structure natin. Dito naman, nakakapagpadala ako ng 35. So, ibig sabihin, there's already capacity that's 3.5 bigger than the existing cellular technology. Now, frame structure then, LTE can only have as much as 20 megahertz of bandwidth. Yeah, pag pinakita natin dito, yeah, it's somehow there's a correlation, no? Kasi mali talaga yung capacity niya at 20 megahertz lang. This is again a 3GPP standard. So wala kang makikitang LTE all over the world that is using 25 megahertz, 30 megahertz, and 80 megahertz, 100 megahertz of LTE because that's not the standard. You can add some layers, 20 plus 20 plus 20 plus 20, that you can do that. Pero wala kang makikita 80 megahertz na diretso. Okay? Again, sa LTE, wala tayong bigger bandwidth na more than 20 megahertz. The maximum is 20 megahertz. Okay? Wala tayong ginagamit na more than that. For 5G, this is the new introduction of bandwidth. No? Meron tayong makikita dyan na 100 megahertz for the FR1. FR1 meaning frequency range 1 as defined by 3GPP, and FR2 is a frequency range 2. On the next slide, makikita natin yan. And makikita natin dito that even on FR2, you can go as much as 800 megahertz. Though that's yet to be released by 17. Release 17. So makikita natin that there is a big change already in terms of the bandwidth allocation. No? Pag tinignan natin, ito yung mga 5G frequency range natin. If using FR1, no, ito yan, from 400 to 7 gigahertz. Pag naman FR2, makikita natin 26 gigahertz to 24 gigahertz to 52 gigahertz. So pag tinignan natin yan, napakalaki ng bandwidth natin in terms of the FR2 because we're talking about gigahertz. Kaya kaya ko talaga maglagay ng 800 megahertz yan. Kasi tingnan natin dito, 2650 minus, or di ba sabi yan, pag-calculate ng bandwidth natin is 29500 minus 2650, that's equivalent to how? How many? 3,000 megahertz of bandwidth. Or meaning, meron kang 3 gigahertz of bandwidth. Ganun kakapal ang ating spectrum na allocated for 5G. Pero syempre again these are standards na ni-release ng ating 3GPP, but it still depends on what is licensed to a particular operator. So, halimbawa, kung operator ay licensed lang to operate at 1 gigahertz, no? Then it can add 800 megahertz or dalawang 500 megahertz na configurable. So, that's dependent on the allocated by your operator or allocated by your governing body or yung spectrum governing body ninyo. Sa Pilipinas, depende kay NTC yan. So, mayroon tayong taga-NTC dito, Sir Julius, no? Hi po sa mga taga-NTC yan. So, ayun po yung, I think they're very familiar with this one because these are the licenses that we are applying for and being approved. And of course, we are paying this one, the licenses, to operate at certain bandwidth. So, yung mga gumagamit ng yung mga may nakikita ko sa Facebook, yung mga gagamit daw ng mga signal boosters, no? Bawal pong gamit ng mga boosters kasi these are unlicensed, no? Lalo na pagka galing sa black market. Pagka nahuli kayo na NTC, I think there's some penalties that you have to pay. No? Kasi frequencies are licensed talaga to talagang binabayaran yung mga lisensya na yun. And we cannot just jump over certain frequencies that are not licensed to us. No? So if you're planning to put up a service, no, ng signal, you have to go to NTC and ask for permission and pay the amount, no, or pay the service or tawag ito, license fees. Okay? So now, no, on the FR1, makita natin that are there lower frequencies. Meron din tayo na tawag dito na duplex mode. Very familiar kayo dito, frequency division duplexing, meaning hinahati natin yung ating downlink at uplink through frequencies, meaning meron akong specific uplink bandwidth, meron akong specific downlink bandwidth. Pag sabi naman natin TDD, we are using the same link for uplink at saka downlink. It's just a matter of time, no? At milliseconds period, pinaghatian natin yung ating downlink at saka uplink. Yung pag-send ng data at saka pag-receive ng data coming from the tower and coming from the user. At saka meron siyang time yan. Now, pag tinignan din natin dito, no, there are specific frequency bands. Bakit yan napaka-importante ng mga bands na to? Tatandaan natin na itong mga frequency bands na to, like N1, N yan, at tsaka N256, 258 yan, napaka-importante po niyan, no, pagka nag-usapan natin yung 5G. Alam niyo po ba bakit? Because the devices that you will purchase in your next payday, Sir Julius, no, sa next payday mo, pag bibili ka ng phone, make sure na siya.
Wala pang budget.
Wala kang budget.
No, I'm waiting for my refresh.
Yun. Bili ka ng 5G.
Corporate.
Yun.
Globe. Pero ewan ko kung
Thank you.
si Hazel magbigay pa. You know Hazel? Hindi, si ano siguro.
Yan.
June yung ano ko refresh.
Yun, pag sa-refresh mo sir, kapag bumili ka ng phone na 5G, make sure that you will check the specification. Or sabi nga ng isang commercial, you have to check the label. As always, no? Tignan mo dito kung yung 5G bands mo ay pasok ba dun sa 5G bands na ginagamit natin, no? Ang guidance naman is really for us to use this frequency, no? To operate. I think NTC has licensed us to operate at this, saan ba yung aking pang-annotate? Mga kaibigan po natin, even sa abroad, no? If you're purchasing your own 5G device, make sure that the services that's being offered by your telco in there is compliant and at the same time, yung device mo ay gumagamit ng certain band. So, halimbawa, itong N77, 78, and 79, these are the frequencies na commonly used, no? And even sa atin, yun yung naka-allocate sa ating region. You can make sure na dapat N77, 78, at saka 79 po yan. Kasi pag nag-check ka ng phone, halimbawa, serious, bibili siya ng 5G, no? 5G phone. Gusto niya ng, ang tawag dito, gusto niya ng iPhone 12. Kaya lang sa iPhone 12, sir, wala pang nakalagay dito na bands, no? Pero baka mayroon na updated si Apple kasi nirelease naman na ng phone nila. Dapat nakalagay dito yung bands. Kagaya nitong kay Galaxy Note 20, oh, pag tinignan natin yung, I can zoom this one, no? Na-zoom ba, Sir Julius? Nakikita ba na-zoom?
Yes.
Okay. So yan, no, nakikita natin that it's using sub-6, NSA-SA, tapos gumagamit siya ng 5G bands. Apparently, dito no, hindi siya gumagamit ng bands na ginagamit natin. So make sure, pagka bumili ka ng Samsung Galaxy Note 20 Ultra 5G, you have to find the 5G bands, yung N77 at saka N78 natin. So natin makikita yon. Wala dito. Itong Huawei Enjoy 20. Yan, naka 77, 78, 79. And I think there are other variations, no, kasi depende naman yan sa chipset na gagamitin ng phone if it will support yung ating 77, 78, 79. Kasi
Balik na lang ako sa 3210.
Ganda yan. Maganda yan, Sir. Yun is classic na classic. 3210, kahit ihampas mo yan sa hammer ni Thor, hindi yan masisira, sir. Baka plastic pa yung hammer ni Thor, no? Yun na, make sure na you are using the right bands. Sa atin, you can check that 77, 78, 79 are being used and applied by NTC for us to operate, no? Pa-check na lang po lagi pagka mag-test po kayo ng device po ninyo. So clear from the frequency na ginagamit natin in frame structure, because it's coming from the bandwidth, makikita natin later on paano kinakalculate yung bandwidth natin, and of course the phones, kasi without the phones, you won't be able to measure yung 5G speed natin. So now, another thing with 5G frequencies and bands, no, with using what we call the OFDMA, no, or orthogonal frequency, pag-usapan din natin later on, the 5G kasi air interface introduces a better filtering techniques. So makikita natin with LTE kasi, no, is NTC a member of 3GPP? No. Organization, there are international organizations now that are part of the 3GPP. So, walo lang yun. But what we can tell is every region should comply. Not a member, but rather compliant to 3GPP.
I understand, I think NTC is represented sa ITU.
Yeah, correct. Yeah.
Not sa 3GPP.
Yeah. So, pero I think ang question dito ni Sir Michael, no,
He's the Vice Governor. Vice Governor.
Sir Michael, ang baka gusto na pong sabihin is, si NTC ba ay tumitingin ba ng frequencies nila ito? The answer is yes, no? Kasi we are implementing 5G din, so dapat compliant din po sila dun sa 5G frequencies that's released by 3GPP. So dapat align din tayo doon with that. Yeah. And of course, no, hindi makakapag-apply po ng lisensya ang isang telco without knowing this stuff din. So dapat align si NTC at saka si operator, kasi yun yung bibili nilang lisensya to operate. At saka naka-define po ng technology ang gagamitin on that specific frequency range. So I hope that answers the question, Sir Michael. Yeah. So now, with 5G, no, it has a better filtering technique. Kaya yung tingnan mo, in terms of efficiency pa, makikita natin that's already 98%. For LTE, it's not mentioned here, or it's mentioned pala, ano, yung guard band na ginagamit natin to prevent interference from other bands is around 10%. So ibig sabihin, kung meron kang 20 MHz of bandwidth, ang usable mo na lang, removing the 10% would be 18 MHz. Okay, because you have to allot 1 MHz from your left and another 1 MHz on the right. There's another question here, no? Sir, as of now, telco here in the Philippines are using FR1 only, wala pang FR2. I think yes, no? But for the FR2, this yet to be validated. I haven't seen any publication if there are FR2 that was released. Kasi I think you have to apply to operate at a higher frequency. Kailangan mong bayaran yan at allow tayo ng NTC to operate. So I'm not sure if we can operate already 5G in a millimetric wave. I haven't seen any publication. So correct, FR1 muna po tayo ngayon. Most of the telcos. Yan. So guard band, no? Ibig sabihin, pagka meron kang 100 MHz naman of bandwidth for 5G, ibig sabihin 98% of it, 98 MHz is being used or pwede mong gamitin. Okay? Kasi with LTE, dahil nga 10 MHz lang siya, ang pwede mo lang gamitin is 18 MHz of bandwidth. Okay? So tandaan natin that 5G, kanina nakita natin na sa bigger bandwidth, it can operate into different ranges, no? And it has bigger bandwidth. And this one, with FOFDMA technology or filtered orthogonal frequency division multiple access, would now give us a 98% of efficiency because the guard band are already optimized. Okay? So mas ibig sabihin, kung gagamit ka ng 100 MHz, meron kang 98 MHz na pwede mong gamitin. That's why it gives us a bigger capacity and bigger number of bits that can be transferred over the air. So now, kung titignan lang natin, no, yun nga, yung kinuwento natin, dahil nga LTE, 80 MHz lang. Now, with 98.28 MHz of bandwidth that can be used at 100 MHz, you can now allocate more and more subcarriers. No? Subcarriers naman, ito yung mga carriers that are within a frequency range, no, that can be assigned to a particular user. Okay? Kaya meron tayong tinatawag na OFDMA because that's later pag-usapan natin yan, ang allocation ng ating mga users. Now, for the frame structure, no, na kuha natin that subcarriers are symbol over TTI, it comprises of time. Kasi frame structure, dahil nga sabi natin frame structure, pag tinignan natin yung frequency as it is, meron siyang 3 properties. Tama? Meron siyang tinatawag na amplitude, di ba? Meron siyang tinatawag na amplitude. Meron siyang tinatawag na time, kasi ano yan eh, time domain yan. Let's say, it operates at 1 Hz, ibig sabihin, meron kang 1 cycle per second. So if you have 10 kilohertz, then there could be 10,000 cycles within a second. And it's bounded by time, no? Kaya meron tayong time. And of course, yung ating tawag na phase, no? Makikita natin yan later on. Now, ito yung pinaka-frame structure ng ating radio technology, or it can be LTE, it can be 5G. Both kasi uses the same frequency structure or the frame structure. Pag tinignan natin dito, no, ito yung laman ng ating tinatawag na bandwidth. Makikita natin dito, on this side, meron tayong tinatawag na subcarriers. Ibig sabihin, this domain is what we call the frequency domain. Meaning, yes, sabi natin 1 Hz, 2 Hz, 3 Hz, 4 Hz, and even up to 35,000 Hz. Or what we call the 35 kilohertz. Or 35 MHz, no? Or millions of Hertz, millions of cycles per second. Nandito pumapasok po yan. Now, meron siyang other element, which is the time. Or tinatawag natin transmission time interval, or TTI. Kaya itong bandwidth natin, subcarriers and symbols, are very specific. Because, pag tinignan natin ito ang tinatawag nating bandwidth, no? For subcarriers, yan, meron tayo 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 na subcarriers. Ibig sabihin, meron kang 12 pa na different frequencies, nakahati sila into 12 because this is a frequency, and meron kang time na 5 seconds. Or kung titingnan natin to, no? This one is a 10 millisecond period, at pag kinuha natin ang isang slot, that would mean 1 millisecond. Pag hinati natin siya into 2, meron tayong 0.5 millisecond. Yung 0.5 na yon, hinati siya into 1, 2, 3, 4, 5, 6, 7. Mamaya, titignan din natin yan. No? Ibig sabihin, meron akong 7 symbols that are within a particular TTI, and meron akong 12 subcarriers. So kung drawing ko lang ha, for us to understand lang, sabi natin kanina, itong TTI na to, dahil nga hinati-hati natin siya, meron akong 0.5 millisecond. Ngayon, yung symbol daw natin, hinati natin siya into 7. Bakit 7? Later, pag-usapan natin yan. Natanda natin yung numbers na yun. Baka lumabas sa next question, Sir Julius, manalo tayo ng Gcash, ha? And subcarriers natin, meron tayong 12, no? Okay? So, kung next ko lang, ha? Next ko. Yeah. Di ba, meron tayong 1, 2, 3, 4, 5, 6, 7. Meron tayong 1, 2, 3, 4, 5, 6, 7, 12. Balikan lang natin, subcarriers are 12. Symbols are 7, and they are bounded by time in the span of 0.5 milliseconds. I hope that that's clear, no? You can raise your hand pagka may tanong po kayo. Pero sasabi natin dito, in the structure ng ating 5G or even LTE, meron tayong 7 symbols, meron tayong 0.5 milliseconds, meron tayong 12 subcarriers. Bakit kaya nagkaroon ng ganyan? No, bakit mo dinidefine yung mga ganyan na numbers? No, yun yung magandang tanong eh. Bakit kaya may mga ganyan number? It's because 5G and even LTE is using what we call the subcarrier spacing. Subcarrier spacing is defined by the 3GPP standard as well. So kung meron kang 15 kilohertz of spacing, alam natin pagka-frequency, may relation yan sa time, di ba? Bakit kaya, no? Bakit kaya meron tayong 15 kilohertz, tapos dito meron akong 0.14 naman. Dito meron akong 15 kilohertz. No? Ito na. Because, paintindi ko sa inyo, pag kinuha natin ng isang resource element na to, that is focused on one subcarrier, kunin natin yung isa, let's take this out, no? Kunin natin to. I hope na okay pa tayo, mga ma'am, sir.
Medyo matahimik kasi pumasok ka na ng mga symbol, mga kilohertz at saka mga...
Yeah, maganda ito mga maintindihan, Sir Julius, kasi talagang pag natuto ka dito, sir, talagang...
Actually, the bottom line there is that parang hinahati-hati mo rin lang yung di ba? Parang mga evolution sa TDM, sa...
Yes, correct, sir.
Para ma-maximize yung bandwidth. Diba?
Yes, that's right, sir. You have to, kasi with the evolution of new ways of behavior ng mga customers natin, ng mga tao, there are people who wanted bigger bandwidth. There are people who wanted small bandwidth.
Correct.
Why not make a system that will support every requirement? Ito yung kagandahan ng tinatawag nating OFDMA. It can allocate resources based on your need. And, syempre, it will give the maximum or efficient way of communicating by the use of modulation technique. Kung ano yung ganda ng signal mo, kung ano yung laman ng network mo, yun yung ibabato na sa'yo. So, para hindi na maputol yung discussion natin, Sir Julius, itong resource element na ito, kukunin ko, ilalagay ko lang dito. Sabihin natin, ang size niyan ay 0 to 15 kilohertz. Okay? 0 to 15 kilohertz yan. Now, sa time natin, mayroong 0.14 millisecond. Bakit kaya 0.14? It's because kailangan mong i-compute yung time ng isang 15 kilohertz. Alam natin that 15 kilohertz, no, is 15,000. Ganito lang muna, no?
Cycles per second.
Yes, that's correct, Sir Julius. No, 15.
Ako ang nanalo sa GCash, hindi excluded.
There will be 15,000 cycles, no, per second. Tama?
Yes.
Correct, Sir Julius, no? Now, the thing is, this one is governed again by seconds, di ba? Tingnan natin, this is, ilan? Millisecond period time tayo kasi system. Siyempre, kung tao tayo, pag-usapan natin, segundo, kasi yun yung naiintindihan natin. Di ba? Pero pagkausap mo si Flash, si the flash, hindi kayo mag-uusap ng seconds, mag-usap kayo ng nano or even micro or nanoseconds kasi napakabilis niya. Same with systems, no? Systems can communicate at millisecond period. Kaya ang isang segundo sa system, 1 second in the system is equivalent to 1,000 milliseconds. Tama? You agree with me? Now, if i-convert lang natin to into millisecond, so there would be 15,000, no? Divided by ilan? 1,000 para maging millisecond siya. So how many cycles now do we have in a particular second? Di ba?
Marami.
Marami. Oh. So, kaya lumabas dyan, no, pag hinati natin yan, that would be equivalent to 14 millisecond of time. Kaya again, yung 15 kilohertz natin is always governed by a 14 millisecond of period of time. So, maintindihan natin if we move along with this discussion. Clear. Clear? Okay. Sorry. Yan. Sorry. Yan, no, 15,000 cycles divided by 1,000. So that's equivalent to 0.6067 milliseconds per in a particular symbol. Pero later, dagdagan natin yan. So, 5G, the 5G frame structure is really based on what we call the filtered orthogonal frequency division multiple access. LTE, yung ginagamit niya is OFDMA, orthogonal frequency division multiple access. That's create a space between time and frequency to allocate users. But 5G has an even structured filtering. Kaya natawag siyang filtered OFDMA. Tandaan natin yan na LTE is OFDMA, 5G is FOFDMA in terms of its downlink combination. Naman natin that for the frame structure, kung sabi natin orthogonal, no, they are separated by 90 degrees so that pagka nasa peak yung isang signal, nasa lowest naman or yung pinaka zero out natin na start ng signal. So, ibig sabihin, hindi sila nag-interfere between the two because they are orthogonally separated and they're separated by 90 degrees. Now, FOFDMA or FOFDMA in its principle, it can allocate a specific user. Yan. Kaya niya mag-allocate, diba? Ito yung system bandwidth natin, let's say 90 MHz, 20 MHz for LTE. You can cut across the subcarriers, pwede mo hatiin, and then each of the subcarriers can now be allocated to particular users. Makikita natin, one user can be allocated with frequency and time. Okay? So si time 1 at saka si F1, bibigyan natin kay user 1, yung time 2, 3, 4, 5, and frequency 1, 2 is for user 2. And so on. No? Kaya makita natin, time and frequency resource can be allocated to its user. Ganyan kaganda ang OFDMA. Na-maximize mo ngayon yung use of your spectrum. Dati, kung halimbawa, naubos mo itong user mo, itong part lang na to, ibig sabihin, mayroong mga unused resources pag hindi ito gumamit ng OFDMA, kung purely frequency division or purely time domain lang. So, halimbawa itong part na to, pwedeng masayang yan. Pero with the evolution of technology or what we call the OFDMA, na-allocate natin yung mga users na yan by simply allocating its time and frequency per user. Okay? Now, moving forward, no, yan, pag tinignan natin, with subcarrier spacing, kaya tinawag siyang filtered OFDMA because you can use now different subcarrier spacing. That's another evolution of the 5G technology. LTE is using only 15 kilohertz, but in 5G you can use 30 kilohertz, 60 kilohertz, and 120 kilohertz. You know what's the key here? Is that if you are using higher and higher and higher kilohertz, ibig sabihin, you are deciding in a very, very short period of time. Halimbawa, kung naka 15 kilohertz ka lang, no, then you can decide at 1 millisecond. That's somehow, manageable by the system. Pero 5G offered a different way of looking at things. Ginawa niyang 120 kilohertz so that I can decide on even a microsecond. No, hindi lang millisecond na. We're going beyond millisecond. So systems now can decide at this period of time in seconds. So kung ito si Flash sa loob, no, nakikita niya lahat ng mga symbols na yan na nagtatransfer over the air. Pero apparently, we're no Flash, we are human, so ang nakikita natin is seconds lang, which is naka-bits per second na yan. And alam naman natin, we can easily convert milliseconds, microseconds into seconds period din. Just by multiplying, 1 million, no? 1000, 1,000 naman pagka unit. Okay? Now, yun nga, no, balik tayo sa OFDMA, pwede natin i-allocate. The difference with the OFDM lang, without without access, ito yung problema with this one. With OFDMA kasi, no, i-allocate niya yung buong frequency. Let a particular user, this one user, second user, third user, fourth user, if a fourth user would just, first user would require Netflix, no, kailangan niya talaga ng heavy bandwidth. Eh yung pangalawa, nag-Facebook lang, ibig sabihin, ito lang yung kakainin niya resources. Si pangatlo, gagamit lang siya ng YouTube na naka-SD lang or standard definition, ito yung kakainin niya. So imagine yung mga resource na nasasayang. Okay? So with OFDMA, kaya ko pang i-allocate, kaya ko putulin yan in terms of frequency, no? Para hindi masayang yung aking resources. I hope that's clear, no? As represented by the drawing. Ito time, ito frequency. With this OFDMA, pwede ako mag-allocate ng certain frequency at certain user